Here we go. Derivatives of, these are your possible functions. You got f of x could be e to the x, an exponential base e, log base e, sine of x, cosine of x, and then tangent of x. You do need to remember that the derivative of each one, so derivative of e dx is itself. That's why that's a beautiful, Euler's number is beautiful. Log of a natural number is the derivative is 1 on x. Sine becomes cos. Cos becomes negative sine. Tan, on the other hand, is secant squared, or squared of the secant of x, which is the same thing as writing 1 over cos x squared. Okay, so that's the derivative. The reason why, and you notice the formulas here is going to be different to the ones in your exercise books, because I don't want to show you what your textbooks normally give. So what your textbooks normally do is they put a k here, they put a k here, they put a k, and then the derivatives, you have kx. This one stays the same. The k over here becomes k cos of x. The reason why I don't want you to memorize that from your textbook is because when it comes to the exams, students use these formulas and they get it wrong. The reason why this only works is because kx, remember the chain rule, if you were to do the log e of k of x, this is a composite function. This is a linear function within a log function. So if you do the chain rule, you would have found the derivative of the inside. So what is the derivative of kx if k is a number? So think of it as like 2x or 3x. What's the derivative of kx? It would just be k. And then we would say delta u, delta x times delta y, delta u. So you would have said k, this is your delta u, delta x, which equals k. You multiply to delta y, delta u, which just basically means, what if it was just log e of u? What would the derivative be? And as long as you know it's 1 on x, you would then say it's k times 1 on x. But what's interesting is that 1 on x would have had the k underneath, and the k's cancel out. But the point is, that's just a chain rule. What happens in your exams? They don't give you that. This is what they give you. Look at the first one. So if you followed that rule, so exponential e to the kx, the derivative of this, you would say the derivative is ke kx. That's based on the formula in your textbook, right? What's the problem? If you use chain rule, that is not going to give you k at the front. Because the derivative of kx, yes, that gives you k, but that is not kx. That's not linear. That's quadratic. So this is linear. That's why this formula makes sense, that it's k, which is your delta u, delta x, times itself. But over here, when you were doing it, you'd actually have to find the derivative of the x squared minus x plus 3. So what's the derivative? What's the derivative of x squared minus x plus 3? Two x minus 1. This is your delta u, delta x. That's a short form, so delta u, delta x. So it's like saying let u equal to x squared minus x plus 3. And you can see the derivative of that gives you that. Then you would have said take delta u, delta x times, and imagine this never existed. If that never existed, you would have had y equals e to the u, and the derivative of e to the u, that's why I'm saying, remembering your rule, derivative of e to the x is itself. So that means, in this section here, the derivative of delta y, delta u is just the derivative itself. So hence, it's e to the u, but u is this thing here. So you just write it again. That would be the correct answer. But what a lot of students did back then, this is back in 2020, was the first question, is a lot of students followed this formula, and they would have just said k is the number in front of whatever x squared is, and they would have just wrote 1 instead of 2x minus 1. Okay, and that's why I don't like teaching it the formula the way that you have in your textbook. I want you to learn it by doing the chain rule. Okay, so I'm just gonna, yeah. Well, there's actual proof to that, which Pat. You'll need to know a few things beforehand, but the Euler's number, as you go through the proof, it actually ends up being itself, which is one of the beautiful numbers that you have. Yeah. So right now, you take it as a fact for now, just to remember. So for now, remember this. This is what I want you to memorize. Proofs at methods level you don't need to know, but it's nice if you want to know. Here we go. So these are the rules that we're going to have. We're just going to get you to remember the derivative log, derivative exponential, derivative sine, cos, tan. And then I want you to use chain rule on top of that. Okay, so the other rules that you would have learned is x to the power of n. Power rule says that it's n times x to the power of n minus 1. Obviously, if there's an a value, you got to times it by a as well. Okay, so far, how many rules have you learned? You learned power rule. We're now learning chain rule that we're going to add on with this next 6 rules. Okay, so chain rule, for those who've forgotten, delta y, delta x is equal to delta y, delta u times delta u, delta x. You are missing another 2 rules. Anyone remember the next 2 that we're missing? Got chain rule, we've got power rule. This is power rule. And then now we've got all these other transcendental functions. What else am I missing? There's another 2. Very good. So the next few exercises, obviously then product rule, quotient rule. But for now, we're just working on that. Okay, so that's all in your notes there for you to take. We're going to do some examples now where I'm going to do a quick form of chain rule so that you can then do the quick form of the chain rule. For those who aren't yet strong with their chain rule yet, you can do the long method, let u equal to a certain variable, find delta u, delta x, and then find delta y, delta u, and then use that form. That's okay, but I'm going to show you the shorthand method so you get better at it. Yeah? Here we go. So for the first example, I'm just going to clean this up and do it a bit neater. So if you happen to copy it already, I'm sorry. I'm just going to clean it up. This is what I would have done. Question's 2 marks. Why is it 2 marks? This first one is just to find the derivative, and the second one is evaluate f dash of 1. So here we go. First thing I'm looking at, I say, this looks like an e to the x function. Problem is this. That is not an e to the x. That makes it something different. So I know it's chain rule, function within a function. So chain rule, I know then f dash of x must equal to, find the derivative of that x squared minus x plus 3, which we said before, 2x minus 1. Times, and now I pretend as if this never existed and it's just e to the something. Find the derivative of that. It should be itself. So hence it becomes e to the power of itself, which is x squared minus x plus 3. So that's my quick form. This is your delta u, delta x, and this is your delta y, delta u. Okay, I'll do a few more so you get a feeling of it. Now, you don't have to simplify it or factorize it because the question is asking you to find f dash of 1. Next one, f dash of 1. Just means that substitute 1 in and find the derivative at that point, which is an instantaneous gradient. So here we go, that's 2 times 1 minus 1 times e to the power of 1 squared minus 1 plus 3. This evaluates to, what, 2 times 1 is 2, 2 take away 1 is 1. 1 times e to the 1 squared minus 1, so actually it ends up being e cubed. 2 marks, 2020, 5 years ago. Okay, so 5 years ago, that was 2 marks out of 40.
What are the marks?
Sorry? Oh, the marks would be, for the first one here, finding the derivative, and then the answer mark. Let's try the next one. 2010. 10 years before that time. So 2010, chain rule was not a thing that they were really good at. So you guys are generally better at chain rule now. Let's have a look. Chain rule, same thing again. They want you to find f dash of 2. Here we go. Same drill. F dash of x equals. Now again, same thing. I notice it's a log function, but instead of log e of x, that x squared plus 1 is the problem. So I know it's a chain rule. It's a function within a function. So using chain rule, I'm going to derive the inside first. Derivative of x squared plus 1 is 2x. So I know it must be 2x multiplied to, remember this is your delta u delta x, I'm just doing the short form, times, and now I pretend as if x squared plus 1 doesn't exist. It's just log e of something. So the derivative log, that's where you go back to this. You've memorized it. Derivative log of anything is 1 over whatever that thing is. Okay, so instead of log e of x, it's 1 on x. So the derivative must be 1 over x squared plus 1. Yeah, because we know derivative log of x is 1 on x, but since it's log e of x squared plus 1, then the derivative must be 1 on x squared plus 1. This is my delta y delta u. Okay, so I'm doing it in a quick form. And again, putting it together, you get 2x over x squared plus 1. Don't need to factorize or simplify any further, or you can't anyway, because you're really just finding second mark, f dash of 2. Summing 2 in, that gives you now 2 times 2 all over 2 squared plus 1. That gives you 4 over 5, because 2 squared is 4, 4 plus 1 is 5. 4/5, 2 marks. Same thing again, derivative mark, answer mark. How's that feel so far? Yeah, so 2f to 2i is about you playing around with log, sine, cos, tan, exponential. Okay? And chain rule. Sometimes you can then have product rule, quotient rule. Let's have a look at this year. This, actually, we've done something similar to that. Let's find something a bit different. This one. Let's try this one. 2007. Exam 1, 2b, 2 marks. Same drill. Find the derivative and then find derivative at pi on 4. I'm going to pause the video. I'm going to give you, that's 2 marks, 2 times 1.5. That's 3 minutes. I'm going to pause the log function. The only problem is instead of log e of x, I've got log e of tan of x. So that means when you're doing this question, what's the problem? It's that tan of x. That's what you would have let u equal to, but we're going to do a quick form of it. Derivative is, find the derivative of tan of x, which we know is, very good. So the derivative of this gives you 1 over cos squared of x. That's your delta u delta x. That's what this is. Times, now delta y delta u is you have to pretend as if tan x doesn't exist there. You had log e of something. What's the derivative of log e of something? Well, we know from the rules it was 1 over whatever that something is. So it should be 1 over whatever that something is. Well, that something is tan of x. So it should be 1 over tan of x. Can I get a show of hands who got at least the first step there? Good. You can simplify that you want. I wouldn't bother because they're asking for derivative of the function at pi on 4. So really, it's asking you to just sub pi on 4 in. So cos squared or cos of pi on 4, whatever that is, you're going to square it, times by 1 on tan of pi on 4. Here we go. Tan of pi on 4. What is tan of pi on 4? Exact values. Use my hand method or whatever method you want to remember, but you have to know that. Tan of pi on 4. 1. So really, this is all multiplying by 1, so you can kind of ignore that. You just need to work out this side now. It's 1 over cos of pi on 4. What is cos of pi on 4? 1 on root 2 or root 2 on 2. Doesn't matter which way you want to write it, but this is key. So you can either write as 1 on root 2, or you can write it as root 2 on 2. Doesn't matter. But then you're squaring this. Remember, that's cos of pi on 4, and then you're squaring it. So this is a fraction on a fraction. Times it by 1 doesn't make a difference, so you can ignore that now. And let's go. Square of 1 on root 2 just means 1 on root 2 times 1 on root 2. So let's have a look. 1 on root 2 times 1 on root 2 gives you top of top, bottom of bottom. 1 times 1 on is 1. What's root 2 times root 2? Just 2. Because it's root 2 squared, right? Root 2 squared, because you're timesing itself. Root 2, or think of it as root 2 times root 2 is root 4. Root 4 is 2. So that means it's really just saying you've got 1 over 1 on 2. I mean, in literal terms, it's just asking how many halves fit in 1, which we should know the answer already. But even if you didn't know, you can rewrite that. That's 1. This symbol here means divide. So if you actually wrote divide, and you're dividing by half, going back to primary school, grade 4 and 5, how do you divide fractions? Do the reciprocal multiplication. So it's 1 times 2 on 1 gives you 2. How many of you got the second mark, which is the answer of 2? Hands up. Okay, and I'm pretty sure if I read the examiner's reports, they'll talk about fractions here. This is a very typical process right there. They're fraction on a fraction. They like testing students. They test on decimals, fractions, surds, and indices. Those are the most common ones they'll always put in to test your algebra. All right, team. Let's try the last one. Actually, these ones are too easy. This one you'll probably need to know quotient rule or product rule. So if you don't know that, then you can probably skip that one there. But we'll leave there. So what I want you to do now is in your exercise book, I want you to practice these ones. These ones I made up. So you come up with, they should challenge you. Otherwise, you can go through your exercise book and pick your own. But I think those there, if you copy those down, those are good to challenge your way of thinking on how would you approach each of these questions there. That's today's lesson. That should summarize 9F to 9I, just that in general. Okay, so as long as you can find the derivative using chain rule, power rule, transcendental functions, that covers that bit. Then we'll do product rule, quotient rule next session. Okay, I'll stop the video and then I'll